Hello, everyone. My name is Herman. I am the author of AARM and a PM at Vanta. AARM stands for Autonomous Action Runtime Management. It is a system category to define how to secure AI-driven actions at runtime. In today's conversation, we're going to be discussing about why system categories are so important for the security industry, chatting about agentic runtime security threats, the work that we've done with AARM, some of the amazing work of the builders and the practitioners that have joined the technical working group. And then we have some exciting news towards the future on AARM and a collaboration with Vanta. Now, when it comes to system categories and why they matter, I think it's really important to understand why exactly we're working on AARM. System categories define a problem and how to solve it. So if you think of a system category as a shared definition of a class of a security system and what it should do, and we come up with a name. So the industry aligns on a common vocabulary, evaluation criteria, and then builders do compete on quality of execution rather than everyone trying to define their own category. It's a great way to bridge a problem and a solution together, and I'm going to make two prominent examples. So if you think about a CM solution or an EDR, you can immediately relate what a CM does and what problem it solves. And then if I ask you to think about who are the top 3 CM providers, you can immediately think about who those top 3 solutions are. Similarly for EDR, EDR was there to solve more complex threat on endpoints, and you can immediately think about who's the market leader in this space, who are additional companies that are solving this specific problem. Now, when it comes to agentic runtime security, there's no system category yet, and that's what we want to do with AARM. Now, let's explore what that means in practice. Now, if you think about the security posture of AI system, it is no longer defined by what models say. It is actually defined by what models do. Because models today, they have access to private data. They have exposure to untrusted content coming from multiple sources. And they also have the ability to communicate externally. Now, they can call tools. They have privileged access. That creates what is being called in the industry the lethal trifecta. It creates compositional risk that is very complex to handle and manage. So it is important for organizations to think about how can we solve this different class of security threats. The solution to that is really going to think about, okay, we're going to be using traditional security tools to solve that problem. We're going to be applying CM solution for observability, APIs for gateways. We're going to put firewalls in place, prop guardrails. We're going to put human in the loop and AAM, or some sort of user access control. Now, all those solutions will solve part of the problem, but they will not solve the full problem. Because if you think about it, it is no longer a problem of what happens after, but it's a runtime problem. And that runtime problem is solved by accumulating context and evaluating intent. None of these solutions today are built to do that job, because for you to understand prompt injection, you need to analyze session context, understand what happened in the previous tool calls, what were the initiating prompts, and then you can really evaluate intent to understand, okay, is the agent trying to achieve a goal that does not align with the original intent? Now, that creates a new class of security solutions. And I really want to go into the details of then what a AARM system does. And then please consider that AARM is not a software. It's a system category. We define what that category should do. Then we have defined some implementation architectures, but then it's up to all the 32 builders that are already building in the space to go and say, hey, this is how I'm actually solving it. So the first part is really about how you intercept the action. It is important to be able to do pre-execution interception. So you need to be able to intercept all agent actions before they execute. All the tool calls should be intercepted. And then as you do the interception, you should accumulate context about the session and try to understand what is the agent trying to achieve? What's the agent plan? What is the overall objective? Then evaluate that based on static policies, contextual alignment to then understand, can this action take place? And then you enforce different types of authorization decisions. That is, you can allow the action to occur, you can deny the action, you can modify it. That is, the agent is instructed to do something else. You can step it up. That is, you can put the human in the loop only when it's needed, because we were so bored about approving everything that Cloud Code does every day, right? And then there's also options where you can defer until you get more context. So you can't make a decision just yet. So you're waiting for more context to then make a decision. And then all of that should be recorded. Because one of the main problems is about, can users really understand what are the actions that have been occurring with their agents, what they did, and what were the decisions that were taken by the agent, and were they approved? So it's important to have like that layer of enforcement, but also observability. I want to go into some additional examples about the authorization decision, because that is slightly different to what we were used to in security. In security, it's either reject or deny. Now we're in a different space where actions can be allowed or even denied, but also you can modify the action. Because imagine that there's a threat called confused deputy, where the agent is trying to perform an action and it loses context and then goes in a different direction. You can instruct the agent to go back and pursue the right direction, or you can step it up to a human. And then finally, there's also an option to like temporarily suspend the action. Now, what we've seen with AARM builders is that some of these decision types do exist today. Some of them have been created after AARM was introduced, especially Modify. It's something that has been recently introduced, and I'm seeing it in some of the very cool implementation of some of the AARM builders that I'm going to be talking about in a second. Now, from here, you might think, okay, great, you have this specification, it does something different. How does it help when it comes to agentic runtime security? Now, that really goes into the context of, if you think about the OWASP Agentic Top 10, and you look at some of the more prominent threats, then you can see that only a solution that has the ability to understand intent can really be useful to block those actions. For example, think about agent goal hijacking. Then here, an AARM solution can intercept every action before execution, checks where it aligns with the user original intent, not the hijacked one. Or how does rogue agent? Here, if you can intercept all the agent actions, you can really understand if an agent is performing the original goals. But then if you look at the common pattern, it all revolves around being able to intercept action, evaluate that, accumulate context, and then apply policies to determine if the action can occur based on intent. Now, going on to the next topic of what does AARM look like in practice. So if you go to AARM.dev, you'll see that we have identified a set of conformance requirements. Now, in this case, we've defined the system category, what it does, and then obviously we want to help builders build around this conformance requirement. We want to guide them on, hey, these are a new set of threats, and these are a set of solutions that we have identified. And then these are then the conformance requirements that you can either align to or conform to. The objective is to create a shared understanding on how can we solve agentic runtime security, what builders are doing, because if everyone's doing the same thing, then we start competing on quality of execution. And then the most important thing is that when it comes to the practitioners in the space, they have a better tool to understand which company is solving which problem in which particular way, following which angle, and then they can have confidence not on their security posture but on their capabilities. So we have identified 9 requirements, and those are continuously evolving, of what a company must do to be called a AARM solution. That is the pre-execution interception, context accumulation, policy evaluation with intent alignment, authorization decision, tamper evident receipts, that is essentially being able to log everything that happened, then being able to assign that action a identity, either being a human identity, either being an agent identity, or maybe it's something that originated from the agent, but the agent was instructed by a human. Also, we want to do semantic distance tracking to detect intent drift over multi-step sessions, being able to export those logs to other tooling for better integrations with incident response, and then also being able to enforce least privilege. Now, these are broken down between must and should. To get AARM conformance, you must meet the first 6 requirements. So far, we have 3 companies that have achieved AARM conformance. I'm going to talk about them just in a second. Before I do that, I want to talk about an additional interesting component, that is how AARM is built. Because obviously, if you think about how you intercept action before execution, there are different layers in ways that you can do that. You can do that through a protocol gateway. You can do that through a SDK instrumentation, so essentially embedding some sort of like hook into the code that allows you to intercept all the actions. Or we've seen also the implementation of harness. However, other solutions have really gone at the kernel level of a machine. But then there's an additional one, and I really want to push all the frontier models to think about frontier models, but also SaaS vendors building SaaS-based agents enable AARM companies to do vendor integration. Because obviously, I can't control what is within my control. But then if I want to control something that sits within the backend of another solution provider, then I need some level of integration, and that only comes through industry alignment. So I think it's super important that we all align on how we want to do that. Again, so you'll see different types of implementation. Some companies are supporting all of these architectural implementation. We'll see more in the future appearing. Got those. If you think about MCP, CLI, that kind of like a debate that is currently happening, we'll see that debate happening as well in terms of like, how do you go about implementing AARM solutions? Concluding on, AARM is not a proposal. It's a working ecosystem. There are 32 companies building in this space around this specification. They're all providing feedback to the spec. They're working towards creating this ecosystem around aligning on, hey, this is the agentic runtime security problem. These are the solutions in the space, and we all do it under the AARM ecosystem. But obviously, this would have not been possible without the great support of all the technical working group member of people that have participated in making the spec live and really keeping us honest, giving feedback, and spending a lot of time on driving those decisions forward. Before we wrap it up, I really want to take some time to thank everyone in the builder ecosystem, specifically Noma, Runlayer, Formal, Mint FCP, Ultra, Manifold, Operant, Pillar, Certive. Obviously, I'm not going to name them all, but these are great companies building on something that didn't exist until 6 months ago. Some of these companies were funded in 2024, 2022. They were already solving something that was not real. It was just a theory, a bet. And I really thank them that they all joined this community. So, like, think about if you were trying to get venture funding for a company that does agentic runtime security for AI agents when AI agents were not a thing. That is, I think, to me, very mind blowing. So again, great work to everyone involved, and congratulations to the three companies that are getting conformant in the last couple of weeks: Noma, RunLayer, and Formal. And again, also big thank you to all the technical working group, especially Phil, Ken, Anthony, Camille, for all of your contribution, but obviously Kavya and Matthew, you've really contributed to this deeply. And also Sai, Shanita, you were really the one that got this started from the beginning. So thank you so much for all the hard work on that. As I said in the beginning, I have some very exciting news. Vanta and I made a conscious decision of try to understand where is the future of ARM, and then we've made a decision to donate ARM to the Cloud Security Alliance. ARM needed a permanent neutral governing body home, and we believe that the Cloud Security Alliance is the perfect organization to support that. So myself and my team at Vanta, we did review a number of various types of organizations in the space, and CSA felt very much aligned. Jim, Daniela, and I decided to pursue ARM as part of the agentic control plane, and we're very excited to see what's ahead. You're all welcome to join us in the future of ARM, and we're very excited about some of the additional things that we're going to be doing forward. So key takeaways for today are: the agentic runtime security gap is real. We need different types of security systems to manage agentic runtime security. It is important to start with the system category, and we do believe that CSA is the right organization to drive that industry alignment, and we all welcome everyone to get involved as part of this initiative. So, yeah, thank you all.